Long bone external structure and internal structure. We can divide a long bone into different regions. The epiphyses are the expanded ends of the long bone. We find these near joints, and their composition is of compact bone and spongy bone. The diaphysis is the middle shaft of the long bone. It is composed only of compact bone, and it's actually hollow. The hollow area is called the medullary cavity, and the medullary cavity is going to be filled with marrow. The metaphysis is between the epiphysis and diaphysis, and it contains the epiphyseal plate. That is the growth plate in which growth of the bone will occur. Long bones all have articular cartilage. Articular cartilage are on the ends of the bone. It is where we would find the joints. Hyaline cartilage is what composes articular cartilage. It's covering the epiphyses. The functions are to make joints easier to move. It allows the bones to glide over each other with very little friction, and it prevents bones from damaging each other. Without the articular cartilage, when bones would move at a joint, they'd rub up against each other. They would start to damage each other, possibly break pieces off of each other. And so the cartilage is there to maintain the health of the bone and the health of the joint. There are different membranes that cover different parts of the bone. The periosteum is a thin membrane that's found on the outside of the bone surface. The endosteum is the thin membrane that's found on the inner bone surface. Whether we're talking about periosteum or endosteum, they both provide an entrance point for nerves and blood vessels. So nerves need to enter and exit the bone. Blood vessels need to be able to do that as well. During bone growth, osteoblasts are going to lay new bone tissue at the periosteum, while osteoclasts are going to resorb bone from the endosteal side. And this helps the bone to maintain correct proportions and prevent excessive thickness. So as we add bone, we are also removing it at the same pace. Compact bone is a layer of bone. It's also called cortical bone. It has a dense matrix with only tiny spaces in between it. Microscopically, compact bone has osteons. Osteons are cylinders made of matrix, and they are parallel to the long axis of the bone. The rings of the osteon are called lamella. So these are different rings of bone matrix, similar to like tree rings. The center of the osteon is hollow, and that hollow center is called the Haversian canal. Sometimes it's called the central canal. It allows a pathway for blood vessels and nerves to flow through the bone. Now, connecting these Haversian canals are sideways canals that are called Volkmann's canals. They connect the Haversian canals together. They also are providing a pathway for blood vessels and nerves. Lacuna are spaces between the lamella, and that's where we're going to find the osteocytes. So you can see that there's spaces. The spaces will be filled with those bone cells. And then finally, the canaliculus are tiny canals that connect the lacuna to each other. And they can also then eventually connect to the Haversian canal. And what they do is they allow communication between the osteocytes. Here you can see all of those structures together. So you can see how they all fit together and work together. Here is an electron microscopic picture of an osteon. And then here is another microscopic picture of the osteons. One good way to study all of these terms would be to have a diagram in front of you and see if you can label all of those different parts on the diagram. And to really help you study, it would be more helpful to find many diagrams because you need to be able to take your knowledge from one diagram and transfer it to another. So that isn't just in the case of when you're trying to learn the different compact bone structures, but anytime when you're trying to learn different structures that might be on a diagram, learning it on many different diagrams is going to help you be able to really cement and then transfer that information. So we've talked about the compact bone. Another layer of bone is called spongy bone. This is also called cancellous bone or trabecular bone. It is porous, meaning there's holes in these in the spongy bone, and the pores are called trabeculae. These holes or trabeculae are filled with red marrow. And the red marrow that we find in bones, that's the hematopoietic tissue or the blood cell forming tissue. This is mainly found on a long bone at the epiphyses, and then there would be a layer of compact bone surrounding it. Here you can see the microscopic anatomy of the trabeculae of spongy bone. Having those spaces actually increase the strength of the bone. It helps to distribute weight more evenly throughout the bone itself. And here are just some more diagrams that are comparing the spongy bone and the compact bone. So we talked about how red marrow is found in the spaces of the spongy bone. Yellow marrow is found in the medullary cavity of the diaphysis. And yellow marrow is involved in fat storage. However, an individual doesn't really develop yellow marrow until about age 7. Prior to that, all the marrow is red. And that's because since there's so much growth that happens in those early years, there is a continuous need for blood cell production. And so that's why we have more red marrow when we're young, and then it's able to convert over to yellow marrow as we get older. Now, the reverse is also true. If as an adult you have anemia, that's when you have few red blood cells. You don't have enough to oxygenate the body. So if that's the case, it is possible for the body to convert the yellow marrow in the medullary cavity to red marrow. And then if the anemia is under control, the body can then convert it back to yellow marrow again. So these are just diagrams showing the comparison of red marrow and yellow marrow in bones, where it's located, comparing infants and adults. So there is a growth plate on long bones that's called the epiphyseal plate. This bone plate is actually composed of hyaline cartilage, and it's between the epiphyses and the diaphysis. So that's where growth is going to occur. Eventually, when growth stops, that plate closes up. The hyaline cartilage no longer is there. It's just a scar remnant that is called the epiphyseal line. And so in girls, that happens somewhere between age 12 and age 16. And boys, that happens somewhere between age 14 to age 19. And that's because of girls entering puberty earlier than boys. There also seems to be a link between menstruation and when the epiphyseal plate closes. It seems that once a female has her first period, her bone growth will probably stop within the next 2 to 3 years. That's just an average, but that's usually what we can then expect. Boys enter puberty later, so their growth window lasts a little bit longer than a female's. So all of that had to do with long bones. Short, irregular, and flat bones have a slightly different structure because they don't have a shaft, they don't have the expanded ends, so they don't have a diaphysis or epiphyses. Instead, these bones have a layered structure. So they have periosteum and then a compact bone on the outside. And then on the center is what we call diploe. And that is where we would find the spongy bone and endosteum. And the spongy bone, just like it was in long bone, the spongy bone here would be also filled with red marrow. So this is showing some anatomical images of what a flat bone would look like.